Imagine a campfire at dusk, the kind that paints the sky with hues of orange and red. Flames flicker, shadows dance with an almost playful energy, but there's no sound, no crackle. The comforting symphony of burning wood is absent. No pop, no sudden bursts of energy releasing from the heart of the wood, no hiss. The gentle whisper of gas feeding the flame is nowhere to be heard, just silence, an unnerving quiet that defies our expectations. The fire burns hot and bright, a vivid display of energy, yet it's eerily quiet. It's a flame that challenges our very understanding of fire itself, a ghostly spectacle that unsettles the senses, leaving you wondering if what you're seeing is even real. This isn't fantasy, some illusion conjured from thin air. It's a real phenomenon. Silent fire, meticulously created in labs by stripping fire of its voice, silencing the very essence of its fiery nature. For millennia, fire's sounds have meant warmth and safety, a primal signal of comfort and security. Now we witness a flame that's ancient in its origin, yet startlingly new in its presentation. The brain expects noise with fire's chaotic dance, the roaring and crackling that accompanies its wild movements. But here, there's only a sensory disconnect, a jarring absence of the expected auditory cues. It's like thunder without sound, a powerful force rendered strangely mute. Silent fire forces us to question what we know about combustion, challenging our fundamental understanding of this elemental process. What invisible forces have been harnessed to create this calm, this serene and silent inferno? What secrets have scientists unlocked in their quest to silence the flame? This is more than a curiosity, a fleeting moment of scientific intrigue. It's a technological frontier, a gateway to a new era of combustion control and innovation. Controlling fire so precisely could mean quieter machines, reducing noise pollution and creating more peaceful environments, more efficient engines, maximizing fuel economy and minimizing harmful emissions, and new stealth technologies, revolutionizing aerospace engineering and defense capabilities. The journey into silent fire is a journey into the heart of combustion, a quest to understand the fundamental principles that govern this powerful force. It's about taming nature's wildest force, bending it to our will, and harnessing its immense power. Not by extinguishing it, but by understanding it so deeply we can ask it to be quiet, to reveal its secrets in the stillness. In that quiet, we glimpse the future, a world where fire is both powerful and peaceful. The visual paradox is captivating, drawing us in with its strange and alluring beauty. A vibrant flame, full of life and energy, but no sound, a sensory contradiction that challenges our perceptions. It's a marvel of modern science, a testament to our growing mastery of the natural world and our relentless pursuit of knowledge. Silent fire challenges our instincts and invites us to look closer, to examine the very nature of combustion with fresh eyes. It's a story of transformation, of pushing the boundaries of what we thought was possible, of making the familiar strange, and the wild serene, of finding harmony in the unexpected. And in the hush, we might just hear what's next, the whispers of innovation and the promise of a brighter future. So, what exactly is silent fire? What does that term even mean? At its core, it's a real flame, producing both heat and light, just like any other fire you might encounter. But it's been carefully engineered to burn without making a sound. It's a flame that defies our expectations. The secret to achieving this remarkable feat lies in control, making the combustion process so incredibly smooth and stable. This precise control ensures that the usual chaos and the associated noise simply vanish. To understand it better, think of it like comparing two different types of rivers. A normal fire is akin to a rushing, noisy torrent, full of white water and unpredictable currents. Silent fire, on the other hand, is like a deep, calm, and steady flow. The fundamental difference between the two lies in the concept of stability. Regular flames are inherently turbulent and often quite unpredictable in their behavior, creating all the pops, crackles, and roars that we typically associate with fire. Silent fire is achieved through the precise and careful mixing of fuel and air, ensuring a perfect ratio, resulting in burning that occurs in a steady, unwavering, and consistent process. Imagine pouring rice into a jar. If you simply dump it in all at once, it's a noisy affair. But if you use a funnel to control the flow, it becomes much quieter. Scientists employ similar sophisticated techniques to carefully organize the process of combustion. The result of this meticulous control? A flame that often looks quite different from what we expect, often appearing steady, with colors like blue or purple, and almost machine-like in its precision. It's still fire, but it's been refined and tamed, carefully controlled for very specific uses. Silent fire stands as a testament to human ingenuity and our relentless pursuit of knowledge, showcasing our ability to harness even the most primal forces of nature in extraordinary and innovative ways. It represents the ultimate expression of control and understanding over the natural world. Fire, stripped of its wildness and unpredictability, becomes a valuable tool, ready to shape the future. Even fire, it seems, can be taught to hold its peace and serve a greater purpose. To truly appreciate the phenomenon of silent fire, a fire that defies our everyday experience, we must first delve into the reasons why fire, in its more common forms, is usually so noisy. What are the key elements that contribute to the sounds we associate with a roaring blaze? The familiar crackle of burning wood, that comforting sound on a cold night, primarily comes from the moisture and sap trapped within the wood, rapidly turning to steam as the heat intensifies. This expanding steam builds pressure, eventually bursting the wood with a series of tiny, almost imperceptible explosions. But the deep roar of a larger fire is born from turbulence. As hot air, heated by the flames, rapidly rises, cool air rushes in to replace it, creating a constant cycle of convection. This constant influx and outflow of air creates swirling, chaotic currents, disrupting the surrounding atmosphere. This violent mixing of hot and cold air generates the low, constant roar that we often associate with a large fire, a sound not unlike wind rushing past your ears. And the flame itself contributes to the soundscape. The rapid expansion and subsequent contraction of gases, a direct result of the combustion process, at the ever-shifting combustion front, sends out pressure waves that propagate through the air. A typical flame, especially in an uncontrolled environment, is inherently unstable, constantly flickering, dancing, and changing shape in response to the surrounding conditions, producing a wide spectrum of sounds, from subtle hums to sharp hisses. Every individual flicker, every tiny variation, adds to the fire's complex symphony of chaos. So, the sound of fire is ultimately a complex mix, the fuel breaking down under intense heat, the air rushing in to feed the flames, and the intricate chemical reaction of combustion itself, all contributing to the overall auditory experience. It's the unmistakable audible signature of uncontrolled, energetic burning. Therefore, creating silent fire requires carefully neutralizing each of these individual sources of noise. No explosive or sudden gas release, no turbulent air currents disrupting the flame, and absolutely no unstable flame front prone to flickering. Scientists and engineers must meticulously smooth out every single part of the combustion process to achieve this remarkable feat. Only then, with precise control, can fire burn with a silent grace that seems almost otherworldly. Truly understanding the origins of fire's noise makes the resulting silence all the more remarkable and impressive. Silent fire, in its essence, is a testament to human ingenuity, a triumph over the inherent chaos of combustion. The secret to silent fire is control, specifically laminar combustion. In a laminar flame, fuel and air flow in smooth, parallel layers, not chaotic swirls. Scientists use burners with thousands of tiny holes, letting fuel and air mix at low velocity, forming countless stable flamelets. These flamelets burn in unison, creating a uniform, quiet flame. Premixing fuel and air to the perfect ratio ensures even, consistent combustion. No erratic burning, no instability. The combustion chamber's shape also matters. It can be designed to cancel out sound waves, like noise-canceling headphones for fire. By combining laminar flow, premixing, and acoustic dampening, scientists dismantle the machinery of noise. What's left is pure silent energy. It's a powerful demonstration of precision engineering. Silent combustion is fire, reimagined for a new era. The result? Energy without the roar. Silent fire's most dramatic use? The military. In war, silence is survival. Engines and generators betray positions with their noise. Imagine a drone or generator powered by silent combustion gathering intelligence or running equipment without a sound. Special forces could operate undetected, and vehicles could move like ghosts. Submarines, too, could recharge batteries underwater, remaining acoustically invisible. Even high-power weapons could operate in silence, enhancing surprise and survivability. Across land, sea, and air, silent fire offers a profound strategic edge. It's not just about stealth, it's about rewriting the rules of engagement. The ability to generate power without sound is a game changer. In every theater, silence is now a weapon. Silent fire isn't just for the battlefield, it's set to revolutionize everyday engines. Cars, trucks, planes, and ships all roar with combustion noise and waste energy through turbulence. By making combustion smoother and quieter, we get engines that are not only less noisy, but also more efficient. Perfectly mixed fuel and air mean more complete burning, better fuel economy, and fewer emissions. This could bridge the gap as we move toward electric vehicles, making current engines cleaner and quieter. Imagine quieter highways, airports, and ports, less noise pollution, more sustainability. Silent combustion could transform all forms of transport. It's about power without the racket. The future of engines is efficient, clean, and quiet. Silent fire is the key. Silent fire's impact reaches deep into industry and power generation. Industrial furnaces and factories are noisy and often inefficient. Silent combustion could change that. Quieter factories mean safer, healthier workplaces and less noise pollution. More stable combustion boosts efficiency, saving fuel and cutting emissions. Distributed power plants could operate quietly in cities, making the grid more resilient and efficient. Even home heating could benefit. Silent, efficient furnaces and water heaters, lower utility bills, less energy waste, and a smaller carbon footprint. From steel mills to living rooms, silent fire offers a path to a cleaner, quieter future. It's a win for industry, the environment, and everyday life. The quiet flame is the future of energy. The promise of silent fire is huge, but challenges remain. Scaling up from lab flames to massive engines or furnaces is tough. Maintaining stability at large sizes is complex. Most research uses clean gases, but real-world fuels like diesel are harder to control silently. Making silent combustion systems durable and affordable is another hurdle. Components must withstand extreme conditions for years, without constant maintenance. Engines must also respond quickly to changing demands. Keeping a silent flame stable during rapid acceleration is tricky. Engineers are working on new materials and smarter control systems to solve these problems. Without these breakthroughs, silent fire will stay niche. But with continued innovation, these obstacles can be overcome. The road to a silent future is challenging, but not impossible. Silent fire is more than a quiet flame. It's a new way to think about energy. For centuries, power meant noise and brute force. Now it can mean elegance and efficiency. Imagine cities with less traffic noise, industries running cleanly, and military operations carried out in stealth. This isn't science fiction. It's the promise of silent fire. Research today is laying the foundation for a quieter, more sustainable tomorrow. Fire has been our companion since the dawn of humanity. Now we're unlocking its deepest secrets. The pursuit of silent fire shows the power of curiosity and innovation. Every breakthrough brings us closer to a world where energy is harnessed with precision and peace. The silent flame is a beacon of hope, a symbol of harmony with nature. The future is quieter, cleaner, and brighter, forged in the beauty of silent fire.